lightning talks. But just before we start, I thought what I'd do is put up something that I just found out before the session. So if we can put up the web page. So here is the wonderful web page from stats.labs.apnic.net, and this is the use of IPv6 in New Zealand. Yeah, so the numbers are about the same as everywhere else in the world. But if we scroll down a little bit just to that just to that table, this conference is top. So give yourself a big hand, because you know the IPv6 in New Zealand is deployed so much that when you roll out a conference and 92.3% of the endpoints are capable, you rock. So yeah, there we go. I saw that and thought that was interesting. So in 2 weeks we're top of that graph. Next week it'll get hijacked by South Africa, I'm sure. All right. First up, if you'd like to come to the stage, we have a small lightning talk on behalf of Minok. Thank you. It'll come up down there. You can use it. Yep.
Okay, hi everyone. This is Khalid Samara from Minok BC Chair. Maybe some of you know about Minok before or attend one or more of our meetings in Middle East. Minok is a Middle East network operators group, which is we can consider it as a Middle East version of APRICOT, and it is normally held in Middle East countries like Saudi Arabia, Bahrain, Jordan, Istanbul, Oman, and the other countries in Middle East. Okay, as we all know, as other NOCs, it is non-profit establishing in Middle East. We have targeted network operators, telecom vendors, ISP, researchers, and educational and university students. We always have a lot of major and main topics in our Minok, like APRICOT or SDNOC or all other NOCs. We are always talking about IPv6 deployment, about HTTPS filtering, content filtering, about ISP experiences, security features, maybe something similar to all NOCs in all over the world. Okay, we have till now 15 NOC meetings occurred in Middle East countries, started in Bahrain in 2007 and ended with Minok in Dubai, which took place in Dubai last year. We have 2 workshops. We have around 35 workshop trainees. We have 2 days conferences. And also we have around 155 people attended the meeting. This is just to give you a quick brief about our Minok meetings. We as you can see here, we have advanced routing and DNSSEC workshop during the Minok 15. Also, we have 15, as I mentioned, we have 15 meetings. Started in Bahrain 2007. After that, Qatar, Kuwait, Bahrain, Lebanon, Saudi Arabia, Turkey, Saudi Arabia again, Oman, and what else? Amman, Jordan, United Arab Emirates, and Dubai 2 times. We are trying always to jump from country to other country just to separate to try to make it in all Middle East countries. Something to be mentioned here that we have a very strong BC team, which always trying to volunteering their time to develop a very good program and build a very good successful meetings. Also, RIBE and CC offer Minok meetings with the secretarial work during the Minok event. Okay, we have finally we have our next meeting will be in Istanbul next month, and we have so far around 180 persons registered for the meeting. We have maybe Turkey is the largest country-based membership in Middle East, and we also something we mentioned here. We have two Minok meetings per year. One in March, and the other one will be take place in September. Every year we have 2 meetings. Finally, this is our website, www.minok.org. including all information about Mino, registration, call for papers, call fellowship, and race program. Finally, thank you, and I hope you can join us in next Mino in Istanbul, and the other one by the end of this year in September. Thank you very much.
Thank you. Okay. What I'm going to do now is I'm going to take the slide decks, sort by name.
I win.
Sort by name. Wow. Sort by name of slide deck, which is automatically generated by the web. Yeah, which just makes it easy. So the first one is Faucet by. Well, I think. Let's see when it comes up on here because I want to make sure that the starts with K. Hang on, how did that work? Oh, that's not actually a K. Oh, that's reverse. Okay, so starts with 2. We'll do the one starts with 2. Here we go. Yakov Economy. So Kit goes last. There we go.
Hello.
Okay.
My name is Yakov Economy. So today I'd like to present about CEDEC 2015. So I provided IPv6 network for non-expert conference, non-internet expert conference. Sorry. The CEDEC is the largest conference in Japan about computer entertainment developers. And we have a 3-day conference at Yokohama Pacifico at the same venue as ITF 94. And we have 6,000 unique attendees. And CEDECnet is a volunteer network. And we are providing high availability Wi-Fi network, but we don't afraid of failure. And we try to challenge new things.
So did we.
Yeah. So we are just playing so successful. And so there are about 1,700 mobile Wi-Fi clients, and 65% of the mobile client was Apple devices, and also so most devices are mobile devices, not laptop. This is very similar to the something like on the train or on in the street. So we provided IPv6 only network for them. So I have provided a lot of conference network, but that is for Internet Experts Conference. But CEDEC is not Internet Experts Conference. Okay. So we announced the Wi-Fi network like this. So we just say that we are providing Wi-Fi network. We didn't say that is IPv6 only network. And so I think my work was great because I provided a network with IPv6 only, so for non-internet experts, and we didn't say nothing. We didn't say anything about a V6 network, and that is default network, not a special separated network. And I think that is maybe the world first challenge. And so why we did it is so this conference was held in August 2015, but so the 2 months before that conference, so Apple revealed that so they reject some Apple applications which is not adapted to NAT 6.4 and DNS 6.4. And so this is an overview of the network. So the left down one is CEDECnet. It is an IPv6 only network. So we provided that IPv6 network with a NAT 654 and a DNS 664. And after that, so we connected to dual stack network, CEDECnet 4. And for IPv6 internet, the traffic goes through IPv6 IPOE network. That is a Japanese unique circumstance. So we are providing access network and ISP network separately. And for IPv4 internet, so we use a DS Lite, which is some kind of carrier-grade NAT. And this is overview. And so Mac and iPhones, yeah, that is Apple devices works in IPv6 only network perfectly. But so Android does not work. That is because we just provided IPv6 network with DHCP v6 only. But so according to this Wikipedia, so Android only supports RDNNS, which is using a array router advertisement to provide the DNS server's information, and also PS Vita and the Nintendo 3DS, which is a mobile game clients, not work with IPv6. And that because this conference is for not internet experts, so there are not so many Windows laptops, so we don't have data about Windows. And the impact on game industry, so we announced just this Wi-Fi network is a test bed for future requirement of iOS applications. And game industry persons notice about that, and they try to check their applications about from second day or third day. And we also make a presentation about this conference network, and that was become an article of Game Watch, which is an internet media about Japanese game, and ranked second of the list of the popularity. And also many people asked me to teach about how to build the DNS and NAT64 environment, but we have not prepared for easy procedure to prepare such environment. Oops, sorry. And this is the second day's statistics. So from 9 a.m. to 9 p.m. In total, so about 25% of traffic was IPv6 traffic. And this graph shows mobile stations connected to the Wi-Fi, and the red one shows IPv6 only network. And about approximately 65% devices, that is almost same value of as Apple devices, share of Apple devices, and they are connected to IPv6 only network and works perfect. And we also analyze the DNS queries, and about 12 million DNS queries, and counted by service providers, and we found the top of 10 providers account for 75%. And so also Google is, as you know, IPv6 ready, and so about 56% was quad A query. And this is statistics for DS Lite NAT port assignment. So in usual, so we are using DS Lite or some CGN devices with about 256 ports or 520 ports, but we provided with 64,000 ports. It's special for this conference because we are using just one IPv6. This is type. Use just one IPv4 address for this IPv4 traffic, but the port was exhausted about around 4 p.m. and we deployed another tunnel, yeah, to support this IPv4 traffic. So lesson learned via the CGN port can be exhausted. So NAT is not a permanent solution for IPv4 exhaustion. So content providers can decrease the risk of this communication if IPv6 deployed. So many of ISPs in Japan are ready for IPv6, but not so many content providers such as game companies or another providers are not ready for IPv6. But to decrease the risk of this communication, so they should be ready for IPv6, and approximately 25% of traffic be released to IPv6 if mobile carriers deploy IPv6. And it is important to make a relationship with another industries. So we are just in internet industries, and we are trying to deploy IPv6, but so we don't have we have not had relationship with another industries, but this is a very good opportunity. And this is iOS 9.3, so they hacked get other info to return the DNS, not 64 address by default. And so Ministry of Affairs, Internal Affairs and Communication, which govern internet industry, says 3 large mobile carriers in Japan should adapt to IPv6. My data would be useful for this try. And thank you very much.
Awesome. Thank you very much. While I'm sorting out who the next person is, do we have any questions? No? Okay. If we'd like to put up the next presentation, there we go. I'm going to start the timer. You may not need it.
Yeah. Hi everyone. I'm here putting on a hat for the New Zealand Internet Exchange Incorporated, which is AKLIX, which was created in 2014. We exist. We are now incorporated. There you go. You can look it up. The committee was formed, and the following members up there. You can see there's several of the ISP members of the Internet Exchange are on there, including Cloudflare, who I am, and the Internet Association of Australia Incorporated as well, holding several of those seats. A lot of the members are here. If you want to talk to anyone, come talk to us. Locations, we're in the data center, the Vocus DC, as well as Mayoral Drive Exchange. We're always looking for more members, and more people should connect, and we're about to make that better for people connecting. Members, we have 44 unique peers today, over 10 gigabits of traffic, 5,500 IPv4 prefixes. The full list, or a partial list, is on PeeringDB. For those who haven't updated their PeeringDB, they should. You can visit our website to see the list as well. For any questions, you can reach peering at aklix.nz. The domain name is going to change soon now that we're incorporated. Joe has assured me we'll find something better. Thank you.
Okay. Questions? That's pretty short and sweet. There we go. Next up, we have. Here we go. Thank goodness people can recognize their own slides, although I guess.
There we go.
All right.
Thank you.
Done.
And left and right here.
Yep.
Great. I'm going to try to do this without a microphone. In the immortal words of Monty Python, and now for something completely different. You need the microphone. You sure? You can't hear me without?
It's streamed. So,
it's streamed. Okay. Modern tech. Hello. So I'm coming to you as a volunteer for the Shadowserver Foundation. I guess in this space most people have heard of that, and as the chair of the Registrar of Last Resort. The registrar is a special purpose registrar that's set up to sync and quarantine bad domain names. And we can have a discussion afterwards about what we mean by bad domain names, but basically it means no intellectual property, no rights holders, just stuff that's bad for the internet. And so this is a ICANN accredited domain name registrar that exists to hold bad stuff. And it just does that. Very, very simple to explain. A real pain in the bum to implement. A quick problem statement. We see lots of bad domain names. I worked on CryptoLocker back when I was in the, working for the UK government as a cop. I've got a lot better now. And we see these nonsense domain names. Infected machines are reaching out, in this case, to 1,000 randomly generated domain names every day. The bad guys only have to register a handful of these in order to connect with their command and control server, infect your machine, encrypt the files, and demand some ransom. So really irritating stuff. Huge amount of potential space. The sort of shadow namespace that this stuff takes up is about 100 million names. So approaching sort of 40% of the size of the real namespace. Obviously, it's not all registered, but we'd like to find a sensible way to block it or have these domains not exist without replicating the whole namespace. So it's a big problem. The issue is, and the reason it affects not just me in the namespace, which everybody in this room might think is not particularly relevant to them, is that criminals exploit complexity. So today, the name system isn't terribly well regulated, and there's lots of sovereignty issues. You've got a bunch of different countries that effectively assert sovereignty over their bit of the namespace. But we can see this happening with IP and with all sorts of other identifiers as well. So this isn't directly affecting the number space at the moment, but it's something that we kind of need to be aware of. The bad guys aren't motivated by cost. They're buying names often on somebody else's credit card, and they're really quick and responsive. So we put standard defensive techniques. We block this set of names. Well, they then just route around that. They roll out a new binary and work around that next week, next month. A bit of policy stuff, sorry, it's a dirty word. The public response, I'm allowed to say this because I used to work for the government. Court orders suck. If anybody's had to deal with one, something called an MLAT, Mutual Legal Assistance Treaties, typically 4 to 6 months for one government to ask assistance of another one, so that's asking for evidence or asking for something to be done outside your territory. We've seen them go over 12 months. So in other words, you can be waiting for a year to get anything from another government. International cooperation doesn't work, and sometimes cops, as we all know, aren't incredibly gentle. So we've seen overreach in a bunch of cases, and obviously, if you've been following the news, that's happening right now. And there's no, and we're in a position where we haven't got much case law. This is all really new still. The private response isn't brilliant either. Anybody who's sort of keeping an eye on this space might be aware there's a bunch of companies converging to sinkhole bad domains that sell. What they'll do is they'll buy 1 or 2 or 3 domains in this space. They'll register them. They'll see the victims that pop in. So every day, thousands, millions of victims will connect to one of these domain names, and then these companies will sell that IP, that victim data. So all of these sort of threat intelligence feeds you're now seeing advertised and sold at huge expense are basically derived from this. These companies buy a few domain names, they work out where the bad domain names are, and then they sell that victim data back to companies. Shadowserver just gives it to you. So that's a little plug for Shadowserver. And there's actually no incentive for anyone to fix this problem. It's making loads of people a good amount of money. So there's some serious perverse incentives at play here too. As usual, it comes down to money. So rather than whinge, I stupidly stuck my hand up at an APWG meeting and said, I'll fix this. And that was 1.5 years ago, and I haven't fixed it yet. So I need your help. The idea that we've come up with is actually to have a registrar, and we can slide in amongst all those other commercial registrars and pretend to be like them, but actually we're there covertly. We're a trusted registrar that security folk can use just to put bad domain names in. So we can take existing domain names. If they're in a domain generation algorithm, that's the fancy word for the stuff I described earlier on, we can register them for people, and that includes everybody in the room. So if you're being affected by something, you can get accredited with us or vetted by us and hand us bad domain names that are affecting you. So whether they're phishing your employees or there's an APT at loose in your region, we can take a look at that. And the really cool thing is that we have a fail-safe model. So unlike registrars, if you don't pay your $10 every year, your name gets dropped. Thanks very much. We commit to looking after those bad domains until they're no longer harmful. So it's a reverse model. That means money. And that's an interest, and at the moment, that's what we're fundraising to do. So we're, one of the things we do on behalf of our reporters, our customers, is negotiate for cost abatement. So we actually negotiate with the registries to say, this is a bad thing, you should waive the fees on this. And surprisingly, quite a few registries have gone for that. So we've got much less opposition from registries than we thought. So it's free to you as the reporter. We're non-profit, just like Shadowserver, neutral, politically neutral, we'll talk to anyone, and impartial. And there's a bunch of ethical checks and sanity checks that we perform before we do anything to take domains down, because obviously that can be, if we get that wrong, that can be a big problem. Yeah, the idea is that it's about managing risk and strengthening due process so that people can say, come back with a warrant. So the idea is that the people that are dealing with law enforcement, it acts as a buffer between law enforcement and other people making egregious requests of internet companies, registries, registrars, and so on and so forth, and allow them to push back a little bit. I know this is quite a controversial area, so we got 1 or 2 minutes for questions?
We got 2 minutes
Great.
33.
How about that?
One.
Or have I just finished in 8 minutes flat?
Hey.
In that case, thanks very much.
Awesome. Thank you.
Cheers, there we are.
Yeah. Clapping with a mic is hard. All right, next up we have APRICOT 2016. We have Ray Gao. You going last? All right, Ray Gao's going last. So next up. Okay, Reza. Do you want to roam or do you want to? You do this? All right, so
My name's Reza Shihab, Nokia, formerly Alcatel-Lucent. So my talk today is going to be operational impact of virtualization. So I'm going to talk about what virtualization actually introduces into your network and what are the implications in terms of management and operations. So today you have network functions in your network, routers for example, and these routers run network operating systems, and you might have a single network operating system that you use on different platforms, and these different platforms may have different sizes, different scale, based on what you actually require. So you can actually think of virtualization as you're taking this network operating system and you're putting it on a compute node. So you can really think about it in terms of a different form factor of a network function or a router functionality that you're already running in your network today. So you're putting this function on a compute node. So there's different types of routing functionality. So one example is control plane, route reflector, for example. So today a route reflector runs in your control processor on your router. So this control processor is, for all intents and purposes, it's a compute node on a blade that you're shoving into your router. So you can take this route reflector functionality, you can move it into compute, it's very easy to transition, and it scales very well. So now you have a compute platform. You're controlling the number of cores, the amount of memory you're allocating, so you can scale it as you want to. If you want better performance, better convergence, you add more cores. If you want it to scale better, you add more memory. So control plane is an easy thing to transition to virtualization. But now let's look at the data plane. So data plane is a bit more complex because if you look at a router today, there is dedicated hardware for certain functions. So you might have TCAMs or NPUs or ASICs, and these are used for packet processing. Right, they used to do your ACLs at line rate, your packet marking, your queuing and your scheduling. Now you need to take these functions that run in dedicated hardware today and you need to run it in software on a compute node. So you need to start looking at things like, if I'm going to build a whole lot of queues in software and do scheduling in software, is it going to impact my performance and throughput? So these implications, so this is what happens when we virtualize. So what are the implications here? So today your network vendor, when you buy a platform from them, gives you some engineering guidelines. You may validate these in your network based on your requirements. But now you as a service provider, you have control on the platform that you're using. you have control of the number of cores, the amount of memory that you're actually allocating for these network functions. So it's not realistic that the network vendor is going to be able to validate all these different permutations of platforms you're going to run on. So they'll provide you some guidelines, but you now need to take greater responsibility in terms of the functions that you put, especially for data plane, when one thing affects another. So the implications are you potentially need to now allocate more resource to deploy virtualization in your network. And capacity planning today, so today you'll monitor certain variables in your network. This might be bandwidth, it might be the number of routes that allow you to anticipate when you need to upgrade the network or roll out the next network function. So because of the implications of certain functions impacting other scalability functions as well, you now may need to monitor more variables in your network. Deployment options, so you have a choice of what hardware platform you deploy on. You may also have a choice of what software and what hypervisor you actually run on these platforms, and a choice on the cloud management platforms as well. So what are the implications of that? So the first one is operational expertise. I'm sure you all have IT teams that are quite familiar with the server operating systems, hypervisors, and applications. But the question is, do your network teams have this expertise today? So how do you actually ramp up these teams? Do you utilize the expertise in your IT teams, or do you ramp up your network operations teams? Fault management. We now no longer have a one-to-one correlation between a network function and a piece of hardware. So one piece of hardware, a compute server, may have multiple functions. So when it fails, it may have a bigger impact on your network. You may have a network function that's actually distributed across multiple of these compute nodes. So if a compute node fails, you may only be failing part of your network function. So how do you cater for that? Configuration, you're now no longer just configuring the router, you're configuring the virtual machine that the router sits on. You're configuring the amount of core and the amount of memory that you're actually allocating. Performance and assurance management. By virtualizing, we've actually introduced additional layers into the network. We now have a compute node, it's got an operating system, it's got a hypervisor in there. So how do you correlate the health of your network function to the health of the actual compute node? So you need to look at tools of how to do that actual correlation. Security. So your hardware routers today will have some hardware in the line cards, or they have some hardware in the control processes that actually protect them from DOS attacks. So when we virtualize these functions, we're still connecting to the network, we're still connecting to customers, we're still connecting to public networks. So what do we need to do in the software to actually provide the same level of security with these virtual network functions? So that's just a really high-level view of the issues that are faced. So no time to actually go through these solutions. There are solutions for these that are being worked on in the industry. They're available now or being worked on. Also wanted to quickly touch on what's new in the network as well. So today, network vendors sell software, but they don't do licensing because you can only run the software on the platforms, the hardware that you buy from them. So licensing is not a key issue. But when we go to a software-only world, licensing becomes important. So you need to look at how you actually do your license management. Do you need to open up your management network to the internet so that you can actually go and pull a license from a public server? Or do you need to actually implement a license server inside your network itself? So there's implications of how you actually do license management. Lifecycle management as well. So virtualization, there are benefits of virtualization in terms of how quickly you can spin up these functions, right? But as you scale up and you scale out these network functions, you need to look at how you do your lifecycle management. So onboarding, instantiation, scale up and scale out. Orchestration and SDN. So a network function, a router, for example. Sorry, I got a call. So a virtual network function, a router, for example, may have control plane, may have service plane, may have data plane. And each of these components may be able to be instantiated individually on different virtual machines and scale differently as well. So when you orchestrate a virtual network function or router, you may be creating multiple virtual machines across the network. So you need to orchestrate this, you need to be able to connect them together. And not just connect these functions together. You're virtualizing network functions, you're centralizing them. It doesn't change the location of where your customers are located. So you need to look at how you actually bring your customer traffic back to these central locations. So you might need to look at SDN and network programmability as well as tools to enable you to actually still deliver your customer traffic to these central network, centralized data centers. So that's just a very quick summary of virtualization impact on operations. I am at the Nokia booth today and tomorrow, so if anyone wants to come and have a chat, happy to have that discussion.
Nice, thank you. Okay, next up. Here we go, Barry. I think it was the latest one I had. All right. Do we want to go to the next one? And I'll work it out? Okay. After Barry. Hey. Good from Riaz.
Right, so this is, Faucet is a switch that we developed at Behance in open flow control things. The idea was that we've made all these prototypes and proofs of concept things, but they were very heavy on the proof of concept and not really actually real deployment. So we wanted to ask, what would it actually take to, well, we deployed them, yeah, but what would we actually...
Harsh but fair, harsh but fair.
What would it actually take to have something that we were like confident that we could deploy in the core or for a member? So we thought about what it would take. Oh, I can look over here. And yeah, what did we really need before we could do that? So it's got to have good software. You know, we have to trust the software. We have to trust the hardware. And then once we've got that, we actually have to have deployed it somewhere extensively so that we can actually see that it's actually working in practice. Our team has to be able to operate it, and you know, we have to be able to monitor it. It has to work with all of our existing tools. So what we built was the simplest thing we possibly could. Well, one of the simplest things we could, which is just an OpenFlow controller controlling a device doing layer 2 switching with VLANs. We figured that if we were going to eventually build something that we wanted to put in the network, it's probably going to have to do some kind of layer 2. It was something we had quite a small time frame for developing it as well. So, and it was also being developed by a couple of network engineers and not software developers, so paid to focus on something simple. So we started with a fork of something made by the one group at Waikato called Valve. And we had to add a bit more code to make it better scalability, upgrade it to use multiple tables, and add our monitoring. But we've got some nice little features. So the config is in YAML, which means we can do revision control with Git just naturally without having to do any crazy interaction with devices. I can edit the config in Vim rather than some stupid CLI. And at the moment, we have even external people contributing. The ONF are trying to improve the ease of deployability of it so that they can like throw it at people and say, hey, here's something that you can use and hopefully contribute to. So yeah, we had 2 months to build it. We wanted to really focus on testability. It's made in Python and uses the Ryu controller. It's there if you want it. You can fork it and we take pull requests. All right, so that's the software. Then the next thing was the hardware. We had something had to be scalable, so it had to support OpenFlow 1.3 with multi-table, which rules out almost everyone. Has to be reliable. We've ruled out quite a few things now, and it has to be affordable, and I think that really we're quite a small number of things. But these were the ones we tried. Arista did not support multi-table correctly. The edge cores, we could not get it running, so that left us with Allied Telesis. So Allied Telesis have actually really been great. We've worked with Tony from there. He's been giving us heaps of support. They've actually been really amazing. So yeah, we wanted to work out where we could test it. Given that it was unproven software, pre-beta firmware, and we had to be somewhere close to our engineers, it's our office. So we've had some issues. Certainly in the early days, the firmware was not super reliable, but we've had plenty of help from Tony. He's had taken our feedback and given us lots of updates. We've actually got to the point where we've got the beta software now, rather than what we had before. And for the most part, people aren't really complaining. I was going to have a slide here which was going to be something like, look, we've had months and months of uptime, and then it crashed like the week before my presentation a couple of weeks ago. I haven't actually checked since then, but I haven't noticed it crashing in the meantime. But anyway, that was one data point. That's an office of 25 people. So we wanted to think about where we could do that. So harking back to the first talk here, we decided to secretly deploy it at a conference. So
possibly go wrong.
Yeah. So we straight away found a bug that was meaning that the Wi-Fi didn't work. And this slide is from the presentation, my presentation at the talk, so that was on the first day. We did not get a port virtualization mirroring up. But yeah, we tried it and we found that it scales well to 25 people. 120 people does not really particularly scale all that well at that point. We had to sort of roll it back pretty quickly. But I would argue that it was better than the Wi-Fi at this conference on the first day. Thanks.
You're the man. And get off my stage. That's awesome. We actually run a fork of that in the network engineering lab at Victoria University, and it is pretty cool. It is pretty cool. All right, next up, or re-up, or, yeah, there we go. I'm still laughing, that kills me.
Okay, so start on this APRICOT 1. I gave a service bar security talk. We covered these points. 20 APRICOTs later, we're still talking about the same things. There's a bunch of people working on, security issues for quite a long time. We've had many iterations in the world. Thanks to JP CERT, a new effort has been spun out. This is a CyberGreen. It has nothing to do with my name. They spun this up long before they approached me and say, Barry, we need your help. All right, so don't associate it. We're not putting an E on the end of CyberGreen, so not going to happen. Essentially what it is we started with a view of collecting a whole bunch of data from probably the largest set of security threat intelligence data feeds out there in the industry, and started from a top-down approach. So the first problem we're working on, if you go to the website, the stats at cybergreen.net, is you're going to see a metric per country on what we see as the cybersecurity health of each country. The audience that we're starting to address there are the policymakers, because one of the issues we've run into over the last 5 years, as everybody's been talking about cybersecurity, is policymakers says we need to do something. We need to do something. And then we spin up a lot of wasted effort trying to guide these policymakers to do the right thing and point at the right, target, what's going to be productive. So the idea here is to come up with a metric where you can say between Singapore, Malaysia, and Indonesia, who's doing well and how are they doing. And what we're measuring is different parts of, how many open ports they have, how many vulnerable machines they have, how many botnets they have within the system, all right? And all this is around going towards a theme of being transparent. As some people said, well, wait a minute, you're heading down a path where you're being transparent on a country level so you can compare it. Aren't people going to get upset? They should be. Next step, we're now moving next week to new visibility tools down to the autonomous system level. So then we're going to go through and say each autonomous system, here is your health check for each AS, all right? All publicly exposed. And people say, well, wait a minute, aren't the ISPs going to be upset? And a lot of us says, well, that information is already out there if you know where to find it. All we're doing right now is make it easy for everybody to find it so you can see transparently how people are doing, right? So when we get down to the point of people complaining that, oh, people are not doing BCP 38, well, let's see per AS who's doing BCP 38. So that's kind of like our goal. We're coming up with tool sets where we can actually see who's doing the hygiene work and the cleanup work per network. So that's kind of like what the ecosystem. Right now, we're measuring compromised systems. We're measuring the open ports. We're looking at it empirically with it. Yes, there's a methodology around it. Jose Navarro and a couple other people, Dan Gear, did a lot of the heavy lifting with the algorithms. It's all publicly online. It's saying, here's how we measure. So how do you measure, the actual metric around picking, the number behind it? The math is all out there online. We did some heavy research on that part. The contributors are also out there, so you can see exactly where we're getting the data from. It's a huge list. We're continually adding new members, or not so much members, but contributors to the program to it. National CERT teams, we would tell them, use CyberGreen as a way to get access to toolkits, threat intelligence that you don't have access to. And then we also have APIs set up, so if you want to take some of the stuff off of CyberGreen and feed it into your own tools, we got APIs set up, so you actually can plug that into your own tool set in your SOC. What we're looking for right now is basically people to start looking at the site, seeing what's going on. And if you're interested in getting involved or participating or tying into it, contact us. And especially when we move down to the next generation of our toolkits where we're getting down to a per autonomous system level. So I bet you many people in the room here who are operators may be interested at that level. What we're also interested in is security professionals who are working on takedowns. We're going to be using this tool to actually set things up over the next year where we actually run an exercise where we say, okay, if this country is degrading over time because of X factor, what if we surged in that country and did certain things? Let's go out there and produce some prescribed cleanup behavior. What will happen? Will we make the metric go better? And that's where we're trying to drive this to, is within a year, we can start using it to measure the results of our work. If we need to go in there and get a whole bunch of people trained with a bunch of autonomous systems in a particular country, then we surge and we say, let's send an APNIC training into an area and then watch it over the next couple of months to see if something happened, right? So we start getting empirical in the way we're doing our cleanup. So that's it. If there's any questions, I got 4 minutes. If there's no questions, we can have time back.
Awesome. All right. Thank you very much. Okay, next up. Okay, Rega. I guess that also means last up.
Oh, just want to show of hands, how many of you have ever heard about packet design before this conference? All right, thank you. Wow, so this is $1 million topic.
You can have a look down there too.
Oh, okay. Capacity planning. So capacity planning means 1,000 words to all the providers. No matter you're doing content, deliveries, ISPs, yeah. Dollar, money, everything. Oops. Yeah, basically the goal is the same for everybody to manage the services and the cost effective. Yeah, this is what we hear from our customer. Some of the facts. So a lot of people, so I hear from them is, so they got spare sheet, MRTGs. I'm not saying that's not good. That's maybe not enough. Okay, so if we can do something better, so why not? Yeah, especially, I mean, come to the APRICOT, there's a lot of people, ISPs, so you guys resell your transit services. So, so do you actually want to know that how much traffic is coming from your customer and it goes to your paid transit via you? What's the traffic breakdown? Yeah. So first is just doing SMP, interface-centric statistic, volumetric data, interface counters. Yeah, I got 4 gig on this link. What are these 4 gig? Where they're coming from? Where they're going to? I have no idea. Well, next is flow data, NetFlow. NetFlow is awesome. Source and destination IP. At least you know where are them, so where they're coming from, where they're going to. But do you know that how they enter your network and how they exit your network and which exact path they're taking? Okay, this is setting the stage and just general illustrations and showing the common place to export the NetFlow. Yeah, so if we do at the edge, so we don't really want to do at the core. There's many deduplication mechanisms, algorithms, but just try to make it neat and clean. Some use case, some screen captures. So this is simulations, adding the traffic to the core. So we try to simulate adding a new sites with the key customer in the major port. Oops. So the green dotted line is showing the exact traffic flow from all the way at the entry point of the network and towards to the exit point of the network. That's the actual traffic flow and the flowing through the path in your network, passing each of links, routers, interfaces. And the minimap, a zooming view. You got source and destination, of course. If there's a VPN, there's labels. You got a volume, you got like 5 minutes volumes of data, and of course we got hop counts. Trying to do some modifications. So list down all the flows we're trying to edit. So we just change one of the flow from 2.7 meg to 27 meg. No, backwards. Okay, let's check the links between the DCP and the DCPPE. It was 11%. So the summary page gives you an overview about what have you done. Okay, wow, yeah. So we enlarge the flow we amplify this flow from 2.7 to 27 meg. So we see there's 25% delta, 24% deltas change. Assess the impact. So the next use case is simulating the failures. This is quite a common activities because you might take down your core router for Juno's iOS upgrade. That's quite a common operational task. So we can do it from here. Just shut down the router. And you can see all the links actually associated with this router is all went down. Yeah, and in the minimap, there's actually, okay, wow, the previous hop count was 5. Now the whole end-to-end path, still the same flow, changed from 5 to 6. That means when you shut down these LA routers, the same flow in this model, it used to, so the red dotted line is actually indicating the old path. And the green dotted line is showing you the path after the change. Does that make sense?
Yeah, I'm just wondering if there's any part of this that isn't the sales pitch. Sorry if you're a jackass, but I mean, it feels like it's shots of product.
Sorry. Okay.
Sorry.
It's fine. Thank you.
Cool. Okay, we have one more from Aftab.
Awesome, and by the sounds of it, you're really going to want to avoid sales pitch on this one.
No pressure, but.
This is not a sales pitch, please. Anyway, thank you for giving me the opportunity. There was a mix-up in the slide of submission, so it was not submitted correctly, but thank you, Dean. Thank you so much. So I just want to share a deployment experience we had with the white box switches. And thank God you can choose any white box switches. You don't have to buy Dell or anyone else. Anyway, so I have to skip a couple of slides because you can see this one. This is not an SDN one. I have to skip a couple of slides, why and who to choose because short of time. So, but the slide is available, you can download it. And I just want to show this one because the best thing about this slide is just remove the model and the specs are almost identical. CPU is slightly different just because whatever is available to these vendors, they picked it. That's it. ASIC is the most important thing. Everybody's using Broadcom Trident 2, and they work absolutely identical. Nothing wrong with any of them. Same is the case with the 40G switches. Again, CPU is the only difference. Trident 2 chipset. So vendor selection, you can select anyone, whichever is available in your region, whichever is available, whoever can provide you the switches as quickly as they can. That's good. The use case, the first use case I heard from, I'm not a Facebook, I'm not Google, I'm not Amazon, why should I use these switches? So they said, you still need a top of the rack switch, so why not? So yeah, so this was quite convincing for only one customer. So first experience with the open network switches, we had a customer who said I have to do this, but I have this much of money. What should I do? He said, we can try this one. How about trying open network switching? He said, I'm okay for a POC. He said, okay, let's do it. So that was our experience. 4 POPs, selection of hardware. We called all of them and asked, do you have a switch for POC? All of them said, no, we don't have it. So we end up buying 2 for the testing. Big risk, but end up quite good. So criteria was simple. Whoever is available in your region, just buy it from them. Same is the case with the network OS. We asked a couple of them, and we said, like, can I try your OS? And only Cumulus said, yeah, the virtualized version is available. You can try it for free as much as you want. It is absolutely similar. It's absolutely same as the original Cumulus Linux. So that would be good. Pika 8 is good as well, but they don't have a virtualized version. You have to use it on your hardware. And unfortunately, we bought the Dell ON switches. Pika 8 doesn't support Dell somehow. So these are the switches, absolutely identical, just you remove the Dell name and they are similar. HP, Dell, Acton, Edgecore, exactly the same body. That was my experience. The moment I installed VX, I said, like, where is the CLI? So if you want to try it, that will be your experience for sure. If you are a non-full stack engineer, I learned it last week. So, but then thanks to Tech Field Day, I end up with this slide somewhere on YouTube, and it explains very well. The whole architecture is pretty similar to what Linux is, so it explains very much. And then you can install Quagga, and then you can find the similar CLI, which is quite common in these days, and people are considering it as a default CLI. So yeah, you can do it. But the most important thing, if you don't save it, it will ruin all the configuration. So please write your configuration before quitting Quagga. I learned it in a very hard way. So that was the POC. So Dell gave us 2 switches at the end, thanks to Dell, not a sales pitch. So we just connected with the multiple 10 gig ports, created a port channel, bond they call it in Linux. I didn't know that before. So, and then we used VXLAN because they were not willing to, the customer was not willing to change their design, existing design. They said, no, we'll keep the existing VLAN infrastructure, we won't change it. So the only option we had was VXLAN. We said, okay, let's give it a go. And it worked really well. And we connected with their existing network, transferred all VLAN from one point to another. In Linux, you don't have to remap the VLAN. It's just bridge. You can use the same VLAN and just send it to the other side. It works really well. But in that process, we broke a lot of things. There is no LACP. VXLAN just kill it. And there is no LLDP. VXLAN again just kill it. And it breaks 802.1p. If you are just doing a prioritization, it just breaks it. So that was a good learning experience for us. But at the end, what we did is like, actually it's not a VXLAN thing, it's a Trident 2 thing more. By the time Trident 2 decapsulated, it's difficult for the Trident 2 to do it, to do the marking again. So we installed another switch because it's really cheap. So we installed another switch right in front of it and did the marking. So it worked really well, but still LACP and LLDP doesn't work. It's a nightmare for operational engineer to do anything. So we told our customer, we don't have to do it from CLI. We'll do it via Ansible. Okay.
That's not FTAB's timer, that's the evacuation alarm. I swear that wasn't me, bro. No. So if you just let... All right, yeah, okay. Make your way out, thank you everyone. It's not the Wi-Fi, okay? The Wi-Fi works fine. All right, just want to get that in there.